Hello everyone, I'm Alan Sakyan. Welcome to Simulation. Today we have the pleasure of sitting down with Reese Jones.
Hi.
Boom, how's it going?
Great.
So good to see you. Reese is definitely one of my favorite people. We have the pleasure of getting to talk to him about blockchain, biophysics, the Singularity. Reese's background's awesome. He is an associate founder of Singularity University, an inventor, an investor. So he's very polymathic. We're going to be walking down a lot of different alleyways together, and we're very grateful to have you on.
Great. Thanks.
You actually, this was really cool because when it was like what six or 8 months ago, we were at Jun Yoon's event and we were learning more about blockchain and we were talking about it a bit. And then you kind of dropped a good amount of wisdom on me, which was you had already kind of found some of the weaknesses in the technology, the energy use, the speed, and you were already kind of figuring out how to potentially fix those things and problem solve and move forward with even more sophisticated technology. I really appreciate that mindset. So maybe jump us into, because your past is so incredible as well, maybe jump us into some of what you've been studying, what you've been inventing over the last couple decades, and then what has come to fruition now from those inventions and investments.
I started out studying biophysics, and my research was trying to figure out the chemical defect in schizophrenia and bipolar using medical imaging techniques and sort of nuclear medicine type chemistry things. And I was planning to be doing that my whole life, but my hobby at the time was phone hacking, and which was something for fun, trying to play with the largest thing people have ever invented, which is the global phone network that's become the internet. And in the process, I learned a lot about how phone parts work and the phone network works, and ended up inventing what's become that blue wire that you plug your computer into the wall with. And that became a lucrative distraction from academia and led to a whole series of companies doing internet plumbing infrastructure stuff. And but my core interest has always been biophysics and how life and biology interacts with technology, and that's led to a lot of adventures over the time.
So this is so cool. So when you were initially doing research in biophysics, you were figuring out you said chemical defects associated with schizophrenia, and what did you kind of uncover from that first, and then what drove you? You were like tinkering, right? You really wanted to tinker, and that's what drove you into this global network of cellular and phone and computers.
Well, the brain is obviously a complicated network, and it runs on a complicated network of chemical reactions, biochemistry, and there's certain things. There's a variation of what is considered normal in brain chemistry, which leads to personality and different kinds of what's called normal and what's called borderline or disordered. And schizophrenia is really interesting thing in that it's something that's intrinsically human and is considered abnormal, but everybody has some of these kind of characteristics.
Yeah.
And it's operating at the core level of what is a personality, what is a mind, what is a person, how do they think, how do they communicate, and so it's a very fascinating disorder, and it turns out to be closely related to bipolar or manic depressive type of disorders, and that chemistry or psychiatric drugs tend to affect these things, and then non-psychiatric drugs like hallucinogens also tend to give people some of the personality characteristics of a schizophrenic might exhibit. And so the early days it was thought that things like LSD were something that was mimicking the what's going wrong in schizophrenia, and thought to be some sort of closely related to how it works. And that was turned out to not be the case, but schizophrenia is still very common worldwide in every country and culture. 1% of the people clinically diagnosed, and several percent of the population being subclinical in terms of exhibiting schizophrenic type things. And so from a biophysics or systems biology or a network theory or biochemistry point of view, this is a really interesting problem. And I was using biomedical techniques to try and figure out, well, what in the brain and in the metabolism and biochemistry is going on that's different, and how does that work? And so the origin of the research was there's a particular carbon network in biochemistry that regulates things, that turns things on and off, called methylation. And it turns genes on and off by methylating the DNA. That sometimes is called epigenetics, and it regulates membranes of cells, including neurons. So it regulates how rapidly neurotransmitter receptors move across membranes, which changes how quickly different kinds of things respond. And it also is responsible for the metabolism of all kinds of neurotransmitters and neurochemicals, including caffeine, for example. And so the methylation of things is the way that biochemistry turns things on or off. And the earlier research had been done of making that particular carbon that is stuck onto things radioactive, and putting that in people and seeing how it eventually comes out. And so it turns out if you make the carbon of an amino acid called methionine radioactive, that's the place that biochemistry uses to methylate things with. And eventually some of that carbon comes out in the breath as CO2. And if you make that carbon radioactive, you can measure it coming out in the breath. And it turns out in a normal person, it comes out at one kind of rate over hours. But in a schizophrenic person, it comes out much faster. And oddly enough, in a bipolar person, it comes out halfway in between normal and schizophrenic. And so the step from going from this methionine through all the chemical reactions into eventually CO2, there's maybe 50 steps in that process in biochemistry. And so putting it in this way and watching it come out that way is different in these different populations. So the project was to figure out, well, what step or why is it different? Maybe there's some enzyme deficiency or some genetic deficiency that explains that. And so the project was making various versions of this carbon and putting it in people. So carbon 13, which you can measure magnetically, and carbon 14, which is a long, slow, mild radioactivity, and then carbon 11, which is a short half-life version of carbon that has a half-life of only 20 minutes, and it emits a positron. And this can be used, traced using brain imaging techniques that are like CAT scans and MRIs, but are called PET scans, for positron emission tomography. And so with PET, you can tell where something is and how it comes and goes. And then with carbon 13 in magnetic fields, you can tell what chemical form it's in. And carbon 14, you can leisurely detect it coming out in the breath and the blood and different metabolites of it. So you're using a combination of these different forms of carbon to follow this network of biochemistry and follow this metabolism over time. The goal was to figure out, well, what's going on. And obviously it's a really complicated project, and I was planning to spend a long time on it. And I did spend more or less 10 years on it. And it turns out that schizophrenia and bipolar is very complicated dynamic and situation. And and the genetic studies of schizophrenia have sort of indicated there's maybe 50 genes that are related to this. So it's probably not one genetic defect in one biochemical enzyme or something like that. It's a much more complicated situation that is not only just the metabolism, but it's also like social cues and environmental cues, so it's a fascinating thing about what it is to be a human and how human psyche works, and how the mind works, and how biochemistry works, and how social networks work as well.
And you said methylation. That's also something that you were teaching me about recently. So how causing genes to turn on or off. And so then with your study of schizophrenia and how you gave that really interesting example about when the carbon, for bipolar as well, the carbon comes out at different times in the breath?
Different rates.
Different rates.
So over a couple hours of time, maybe a couple percent of the carbon that was on an amino acid, part of a protein called methionine, will come out in the breath, but 90% of it is stuck onto membranes and genes and other molecules that don't come out in the breath.
Yeah.
And so that is a really highly conserved part of genetics, not just in humans, but in most biochemical species. And it's used for a lot of really important things, as I said, turning things on or off. And so, like a common one is genes.
And could that be for when we hit puberty, right? We have the genes that turn on for our growth spurt, or for our actual reproductive organs, things like that.
Yeah. So as an organism develops, it has genes that say grow a body now, grow teeth now, grow different sorts of things. And once those are grown, those genes that are doing that need to stop.
They stop.
And one of the mechanisms that they're stopped is a carbon is stuck on that gene, and the machinery that reads the gene says, oh, well, this one is turned off, so keep going. And then other genes that say start puberty now, or start menopause now, or start aggression now, get turned on. So these turning genes on and off has a regulatory network, and that's called methylation. And the percentage of your genome that's methylated is actually a really good measure called the Horvath clock, one of the best measures of how old you are and how long you have to live.
Maybe explain the Horvath clock a little bit more.
And so that's a measure of what percentage of your DNA or what percentage of your genes have been methylated, meaning it's the regular DNA plus an extra carbon stuck on there. And that carbon is like a light switch that the replicating and metabolism enzymes that run along the DNA like a train on tracks comes to that and either works or it doesn't work. And so when you stick a methyl on something, the machinery passes it by and it's basically turned off. And in some cases the methylation turns it on, but that's a more complicated story.
And when too many of the genes become turned off, that is when pathology or disease kicks in.
Well,
and death.
the opposite almost there, where you have genes that say grow a tooth here and now, and that's really important to have teeth, and the teeth grow in the early stages of development.
When the methylation stops working.
Well, and so some cancers, for example, are immortal, and they're growing at the wrong time, and they're expressing the wrong genes in the wrong place at the wrong time. And so, for example, some tumors will actually grow things like hair or grow teeth in your liver. And you don't want teeth in your liver. And that's those are genes being expressed that have normally been turned off everywhere else in the body, but in cancer mutation they accidentally get turned back on.
Yeah, okay. So the pathology can come on from either methylation not working, or from it not working, and then the process that is not supposed to occur occurs, or from it not working in the process that was supposed to occur did not occur.
Right.
So one of those two paths.
Right. But these things are time, sort of biological clocks as to at what time should you go into breeding characteristics where you shouldn't be before and you shouldn't be after. And these things are genes turning on and off, and
That's interesting.
a complicated part of life.
Methylation is another really cool thing that you've been teaching about. I really find that interesting, and I'm glad that your research was in that, and you get these little insights from more research into the field and into things like schizophrenia. And so, okay, so now walk us down a little bit of this whole, networks and communication and internet. So how did you realize that we needed to be connected to like the Cat5? How'd you come up with this? Yeah.
So it's so biochemistry is a network, and so is the brain, and so is metabolism, and it changes over time, which is life, and birth, and aging, and death, and across species. And it's not just in humans; it's the same in plants and animals and microbes of various kinds. And so these are complicated networks of many different factors that change over time. And so is the internet, and so is the phone network, and so is traffic, and so is social networks, and so is the food web, and the way culture works, and the way information flows through culture, like news and memes and things. And these things get turned on and off, and they work in a network effect type way. And so this is all areas that I studied.
So you just connected how genetics and methylation works to how the cultural programming works, because there are certain memes that turn on and then they turn off.
Yeah.
And that's just really fascinating how you can make that connection.
Yeah, and it's a decentralized, distributed system. So life is a decentralized system. There isn't like a president of life or a central computer of life or a central database of genes. They're distributed, and they operate independently, but as part of a network, and the networks have dynamics, and so these are very similar kinds of dynamics, whether it's a news network or a food network or a biochemical network.
And maybe if we zoom out far enough and we look at the pale blue dot, then maybe it can look like a centralized entity.
Well, that assumes that it's the biochemical network life only exists on the pale blue dot, and
correct.
And in all indications, it's not that way.
Yeah. So that was really good. So keep wandering us down this whole understanding of how the life is also like a network, kind of like biology is, and.
Yeah, well, as a person, each of us thinks about how, well, I am an individual person and everything revolves around me. But objectively, a person is part of a complex network. There's their family, there's the food that they eat, there's the information that they transact. And so a person is really a node on a network, and not necessarily a isolated thing in and of themselves. And so how the network affects each of us and how we affect the network is kind of a nuanced problem that is counterintuitive to even notice as an individual person.
Can we say that we're both individualistic in our ability to find fulfillment or find meaning in life and build that thing into the world, but we're also collective in the sense that we are a node on the network?
Well, I would say yes, that's true, but it's not half-half.
What would you say it is then?
It's more like 99% network, 1% self. And that, like, if we don't have food, we're not a self very long. And the food, you have to eat life to live, as much as the vegetarians would think they don't eat life, but they do eat life. And
plant life.
Yeah, plant life. And you can maybe make something like Soylent that is, ingredients of life, but most of them come from life.
Yes.
And so a person and the metabolism of a person or a plant or whatever is very dependent on the nutrients that come from other life forms. And so life is really a network and not individuals.
That's a really ego dwarfing sort of understanding of reality, because we are just a little node on the network of food and of family and work and culture and social media and even your healthcare, your education, everything. You're just a little node on the network, on all these different networks that are then all intertwined into a massive web. And so what else has that realization taught you over the years?
Well, things like ego and consciousness and perhaps free will are illusions that are important behaviorally, but they're actually counterproductive in terms of being a citizen of a network and an ecosystem.
Is it fair to say that we need a little bit of ego to make sure that we don't get maybe hurt or something, that we can maybe ensure that we thrive? So an example is maybe we need to be very aware of our own safety when we're walking somewhere that might be unsafe. Or maybe would that mean that we need a little bit more ego during that time to make sure that we are analyzing our environment, and because the network might not keep us safe in that region?
Sure. Well, so if you think about developing as a person, we start out as an infant that more or less has no noticeable ego, and is very dependent on the mother and the family and the food supply and not really aware of themselves being separate from other. So self and other are all one, a sort of non-dualistic way as an infant. And an infant doesn't necessarily have an ego or even free will, in that the mother decides when it's time to eat or not, and manages safety and other things. And sort of an all-powerful, all-knowing, godlike being in the life of an infant. And as we develop and grow, we mature to feed ourselves and mobilize ourselves. And then when puberty kicks in, the hormonally driven motivation to breed has us sort of look elsewhere from the family and siblings and relatives to find a suitable breeding partner, and that is obviously best if it's not inbreeding or in the same genetic pool. And so one of the manifestations is developing independence and an ego that says, I'm separate from you, or I'm separate from my mother, from my family. And Freud and Jung and all kinds of psychological analysts have thought about this in great detail. But the basic is as people or other species move to breeding age, they separate from their biological family and they go looking for suitable, differentiated breeding partners.
Yep.
And that's driven by hormones, which drive ego, which drive dominant behavior, which drive mate-seeking behavior and separation and that kind of thing, which is something that comes on about puberty time, maximizes a peak breeding and fertility time, but then diminishes later in life.
Yes, correct.
And that more or less tracks how ego goes, and that it's something that is minimal early in life and later in life, but it is sort of maximal during peak fertility time. And so that's something that some practices like Buddhism and meditation are, how do you reduce the ego and how do you eliminate the effects of this personality characteristic that isn't in young people and isn't in older people, but it is in sort of the middle range of life, that tends to be driven by hormones, to be driven to psychological things that we might call ego as one, or aggression is another, that might actually not be so good for life. And so developing practices of how do you suppress that and reduce that leads to a happier life.
Yeah, exactly. That was so well explained. I've been able to find that these 10-day meditation retreats do that for me, or maybe a little bit of psilocybin or LSD or other things can really do that for you, this dwarfing of this ego. So you kind of painted it out really well, that when the child is made into the world, that the child is, the parent as the God to the child takes really all responsibility for it. So the ego isn't really there. Would you say that consciousness is developing in the womb, or consciousness when is the being conscious?
Well, so consciousness is a fascinating topic, and nobody's really quite sure what it is or how it works. And some of the most interesting thinking about it, in my opinion, are people like Tononi or others that have we have different subsystems that fuse together functionally to be consciousness. And there's a saying, I think, from Bateson as where is the edge of a person or of a man? And is it our body or is it our environment? And so they use the example of where is the edge of a man with an axe? Is it at the hand? Is it the axe? Is it the blade of the axe? Is it where the axe could strike? Is it where he could run with that? Yeah. So what defines a person isn't just their skin, it's like their sphere of influence. And consciousness more or less extends to that sphere of influence. It's not just, if something is outside of my skin, it doesn't mean I'm not conscious of it. Or it doesn't mean that it's not part of my being. And so it's subsystems of my hand and my arm and my nerves and the part of my brain that those are connected to are fused into the other side and the other subsystems that are me, to be my consciousness, which isn't limited to my body. And that this extends not just within a person, the right hemisphere and left hemisphere forming one consciousness, but it extends interpersonally. So when you have friends and associates and relationships, you form a joint consciousness with them. So like a couple who knows each other well, or a parent-child family dynamic, they collectively decide when we're tired or when we're hungry and when we should eat and when we should sleep. And these things are a collective consciousness that extends obviously between individuals and family units, but into tribes and cultures and societies, in that there's sort of a national consciousness or a corporate consciousness or a community or religious consciousness that is made up of the amalgam of the many different parts, subsystems. And experiments of like lobotomy, cutting the right and left hemisphere, still seems to have a consciousness, but each side has a subconsciousness that are no longer connected as well and not communicating as well. So that if one hand is solving a puzzle that it can see controlled by one hemisphere, and the other hemisphere can see it too and knows how to solve that problem, the person will actually grab the arm and help solve the problem across the two hemispheres that are normally connected internally, but if they're not connected internally, they're connected externally. So when you're somewhat separated from people you know well, you might text them a message saying, well, here's how you solve that problem. And that's an indirect way to work as a consciously collective unit, in a sense.
And that seems again to play into what you were discussing earlier, which was the whole culture acting as a network, human groups acting as a network. very similar to how systems biology does. So I really find it fascinating that we're continuously coming back to understanding life in this perspective of you are both a conscious being, but you are also very frequently immersed into a collective conscious being with other people. And that changes dynamics so much from an individual to a group. And just to be aware of that process is very important. Okay, so you said consciousness and free will and ego illusions.
Well, so locally, those things feel very real, but from a distance, like the pale blue dot, or even across the room, they are localized. Like like if you have a banana on the table and you go, "I'm hungry, I'm going to eat that," that feels locally to be a free will and a conscious act.
Yes.
But an observer observing from across the room, whether you're a monkey or a human, would say, "Oh, well, that monkey's probably hungry. He's probably going to eat that banana. Yeah. Look, it did. That's biology. That's not free will."
Free will.
And so it's a matter of perspective.
Yeah, I see what you're saying. Okay, so the perspective changes because it's when you're looking at it localized through that kind of the whole like solipsistic perspective. When you're looking at it from behind your own eyes, it looks like and feels like you have free will. But from an observer's perspective, it does look like, it's just biology telling that human for their heart to beat that 100,000 times in the day. Or for them to blink at this second. It's for them to take a breath right now. You just couldn't live without doing those things. So that's why,
Well, and so researchers who study this, like Maureen Cerf at Northwestern, for example, who has electrodes in people's brains while they're waiting surgery for something else, that tracks how ideas are formed and how recognition is formed and how decisions are made, finds that subsystems of the brain decide they're going to do something before you become conscious of it.
Yes.
And so my eyes are telling my brain to evaluate my hunger before I even realize that there's a banana there and that I should eat it.
Yes.
And so these kind of things appear to be, like I'm deciding to do that, where your brain's already decided long before that it's going to do that, and then your consciousness is actually rationalizing the collective behavior in sort of the same way as a spokesperson for a family or a community will rationalize, well, this is what our government did and this is why, where the decision to do it happened before by other subsystems.
This reminds me a lot of Behave, Robert Sapolsky's book. There's how it goes back in evolution for billions of years prior to the actions that I do to eat the actual banana. The effort that goes into the stomach communicating with the brain, analyzing the last day, when was the last time you ate, how many nutrients will you earn from that banana, how difficult it is to get that banana, how much does the banana cost. There's so many variables that go into this. I want to loop Ron in. Ron, what do you think about consciousness and free will and all of that being illusion, or is it real?
I agree with Reese halfway.
Why? Elaborate.
Well, I mean, we are the master of our own destiny, no?
What do you think, Reese?
But I don't think we decide when we're going to have puberty, or very often when we're going to die, or when we're going to find food. That some of these things happen, and then we rationalize I hunted that banana and I found it, and so I'm a great hunter of bananas.
What about the whole destiny, though? What about what Reese Jones's impact is in the world? Do you get to decide that? Because one day you can wake up and decide that you want to focus on biophysics. The next day you can wake up and decide you want to focus on blockchain. So you can choose to do a whole year of one of those things, can't you?
Sure. And so Sapolsky would say it's all biology, that there isn't a free will, and that other people would say, well, free will is a really important part of being human, and that it's everything that we do. And so in physics, there's this concept of a local, like the speed of light and time are local to an observer. And that I would say free will may be, or what appears to be free will may be similar. Whereas Polsky would say it's all biology. And another way to look at it is me deciding to touch this cup. Well, that's a limited free will, and it locally appears to be free will, and it doesn't seem to be motivated by biology, except in communicating point. And that is something that is sort of like a local phenomenon, like the time or speed of light local to me appears to be this. But from a distance, again, a matter of perspective, it may not be as obvious.
Do you think we are masters of our own destiny?
Only to a limited extent.
Yeah.
Ron, yeah? Do you have another?
To a limited extent. We're a machine in ourselves, aren't we? With a higher power calling the shot, making stuff happen, using us. Meet puppets.
Yeah.
We don't decide when and where we're born. We don't necessarily decide when and where we die. We don't necessarily decide a lot of the things that happen in the arc of our life. And so those things are not part of our consciousness, and they're not even in our control, or even awareness per se. And in the middle range, sure, that we might decide what to do, apparently of our own volition, without any influence of something in the network or in ourselves. But I think the 99% of that, maybe our own volition and free will, is 1% of what's happening.
There's a percentage. That's
but
good.
If you think about, we're a biochemical network that is, asking for vitamin A, and we're part of a food network that, meat has that, and then we're part of an ecosystem that has its own dynamics, and so we're a biochemical network in a food network in an ecosystem network. So a network of networks, which is and the manifestation is between the networks, and so that's literally an inter-network, which is the internet. And so our participation in these network of networks is as a node, maybe, but not as a controlling system.
Yeah, exactly. Okay, so that's again the 99 to 1%. Your consciousness, your ability to take control of what you're actually doing within the network is only a very, very small percentage versus what your role is within the network as the node is. That's what the 99% is. Very similar to your free will and conscious control as well. Like you were saying, your birth and your death, and when your genes methylate, and when you get to choose if you want a salad or a burger. And but your consciousness says, I'm going to get a burger because whatever rationalization you have, and however, like your decision to do that may be motivated by other things, like not only your own biochemistry, but the microbes in your intestine. You might not have had a burger for a month, and it really wants one.
And the family of microbes that came from burgers that are inside of you are subtly persuading you to get another burger to repopulate that family with the things that they want. And so in some ways, these microbes are like the jelly in a jelly donut, and the person is just carrying them around and keeping them comfortable. And they may be saying, I want a salad or I want a burger.
Signaling to the conscious being.
And the consciousness is tricked into thinking, I'm going to go get a salad or I'm going to get a burger.
That does feel like what it is sometimes.
It's fascinating.
Yeah, it is. And this family of microbes that lives within us, is that is it true that there's just vastly more microbial cells within our gut than there are even human cells?
Yeah, there's more microbial cells in us and on us, on our skin and so forth, than human cells. But those microbes have different DNA and different genes, and so there's actually vastly more genes that are non-human than are human in an adult.
Yeah, and then the way that they're communicating with us and directing the way that we live is something that we don't even really understand that well yet, and that we're trying to understand better, because apparently it even influences what we think are our conscious decisions, but they are not in many cases.
And our relationship decisions, where we're eating the same food, and in a business decision or a social dynamic where you're breaking bread with somebody to share the same food, to populate, like crossbreed the same microbes and motivations internally, so you're more likely to be in alignment after you've shared food with other individuals than before.
Yes. That's also very good. So the oxytocin, the connection, the trust that you'll have with the person once you've broken bread with them.
Yeah, oxytocin is a really interesting topic in that it's something that's stimulated by sort of maternal behavior and mating behaviors and things like that increases the bonding between individuals, like touch, and it strengthens the local bonds. But some evidence, like Sapolsky talks about this, and Lewis and others, that it maybe strengthens the local connections, but it increases the adversarial distances. So it's both.
Makes you more tribal?
It's both. So at a tribal level, it's sort of like the us and them, and the like our team, their team.
Becomes amplified.
But even in a relationship, it's like, oh well, this person, like jealousy is also a function of oxytocin, where where somebody wants to be in close coupling with a partner. That's sort of an oxytocin type maintained relationship, but that increases the adversarial relationship with other partnership threats. So it sort of increases the jealousy of, that person might harm our relationship, so I'll push them away while I'm trying to get closer to this person. So it cuts both ways in a way. And
and we've been talking so much about how things work as systems. Just having that general understanding is so important. We were just yesterday talking about the importance of having an understanding of history, the present, and the future, because then one can look back 50 years at suffrage and at segregation. And today, if anyone's talking about women's suffrage or segregation in a way that's in favor of those things, then they could make headline news. And so just to have that analysis of where we've gone and how we've gotten there and where we are, similarly to what I'm thinking for the next 50 years, for people to have, we're talking about clean meat in the future, looking back 50 years, it'll be like, why did we do that to so many animals? Why were we doing it that way? It's so great to have the systems that we have now. And I think that same thing will go for an overall ability to conceptualize systems level thinking, whether it be within the body and the biology, whether it be through consciousness and collective consciousness, through culture, what we're doing as a culture, to look back, hopefully 50 years from now, we'll look back and we'll say, how were we not educating every kid to have a general understanding of what is going on inside of themselves, how they interplay with the world around them, how they're a node in the interplay of what's going on in the network. So do you maybe have recommendations for parents to best help their children understand these things at young ages?
Well, I think a non-dualist perspective where we're all connected, we're all part of the same thing. There isn't really an other or a them or a they. It's sort of part of us as including plants and animals,
Exactly.
not just people.
Exactly.
And that of course we need to eat plants and animals if you choose to live, but they in turn need to get resources, and so it's a part of a system that if you're aware of it to some extent, I think you can be happier in life, and that there in a sense then there aren't adversaries except temporary or local or illusional adversaries, but that we're all part of one system.
Yeah, that right there is that's a huge point for what we're trying to help have conversations about on simulation is how do we end up building a better future together? And I think you nailed it. One of the things that parents can help young kids learn is that a non-dualistic perspective about life, about a very inclusive, a very kind of collective, we are one perspective about network theory and understanding how systems interplay with one another. But so many people get scared by collectivism, and so many people get scared by the issues that have occurred in the past with thoughts, schools of thought like that. They're scared of socialism or communism. That they relate that with collectivism. It's almost like a PTSD in a sense, rather than thinking about it in a 5-year or a 10-year or a 20-year. What could collectivism look like where there is so much more access to clean food and clean water and shelter and education and healthcare across the world? How could we grow as an organism, as that pale blue dot in the cosmos?
Well, if you think about it in a 1,000,000-year time frame as opposed to a 5-year time frame, we're part of an ecosystem, and we were 1,000,000 years ago, and hopefully we will be 1,000,000 years from now. And some of these terms are ideological terms that people trying to create a pure ideology based on an idea that isn't completely thought out.
Exactly.
Yeah. And so collectivism is one of those ideological terms.
It's not fully mapped out or thought out in its fullest, most powerful extent yet. And we just,
like where does the food come from? Where does the waste go? How does it operate more efficiently?
Yeah, where does the energy come from? Where does the energy go? Where does how do we provide healthcare access to people without breaking the bank or making it seem like it's complete welfare system? All these kind of questions, and this is why we have these conversations on simulation, because we get so frequently stuck in a binary yes or no to questions, but they're so complicated, they're so nuanced, and they're so fun to unpack in all of their details, because then you lead to better understandings of, like you said, a 1,000,000-year time scale, or even something less scary is like what Long Now Foundation, 10,000-year time scale, because we're not going to survive by having egos go through the roof. I always use this analogy, and I'm interested to hear what your thoughts are on this analogy, but we were talking about this with Jordan Peterson as well. Very competent people understand that helping people brings them more meaning and fulfillment in life, and it almost doesn't make sense to me why one would purchase a third yacht instead of hire 50 people to solve a problem in the world. What do you think about that?
Well, part of that is a fear driven by fear, and fear is largely a dualistic concept that there's something other that you're afraid of.
Yes.
And a third yacht might be that your two existing yachts aren't good enough to overcome your fear of being viewed as not good enough. And so you need to accumulate these things to find acceptance in the network. And that, does the rest of the network
value the 50 people solving a problem?
Well, or do they value you?
Yeah.
And then what you're motivated to do is, are you helping the network in general, or are you trying to manage your fear?
Exactly. If all of the other nodes were to come to a consensus about hiring 50 people to solve a problem is by far the better decision.
Well, it depends on how you evaluate that. The 50 people and the other 50 people who have a lottery of being one of those 50 people would say, by far, that's the better choice. But the yacht builder and the yacht seller would say, no, you should do the yacht.
And there's people that work for that company that
Yeah.
build that as well, and those materials. It's still an economic stimulus and whatnot. So, go ahead.
So doing things exactly the same for all people isn't necessarily the optimum solution.
So it wouldn't be got it. So it wouldn't be like a consensus around there being one option that's absolutely better. It'd be like, here's all of the options, make your decision. But but that also doesn't seem like it's optimal either. You can't have an economic system and financial markets on a finite planet that just have all of these options and say, do whatever you want to do.
Well, hidden in that sentence is the term finite planet, and that, this planet, if you just look at solar energy, isn't finite. The resources that are on this planet are coming from somewhere else. And so there's a flow of energy in, there's a radiation of heat out, there's some of that energy is turned into food and people and rockets and stuff. And so it's an open system, and it's not finite in that it's in a locally infinite solar system and galaxy and so forth. So it's part of a larger whole, as opposed to being the whole in and of itself.
So besides the star powering the Earth, what else provides infinite resources?
So our perspective, there's a saying that the Stone Age didn't end because of the lack of stones, in that it's a perception of, well, what is the necessary ingredients. And like the oil age is probably not going to end because of the lack of oil. It's that people find alternatives that are better.
Correct.
And so the infinity of it is the alternatives that have yet to be discovered, or maybe they're very obvious right in front of us, but they're yet to be noticed.
Yes, correct. And so that's indicative of overall progress from Stone Age to Bronze Age, etc. Similarly from oil to solar, etc. Great. But should there be some sort of an ethical consideration around financial markets? Or even an ethical consideration around business in general, because a lot of millennials and a lot of Gen Z kids are starting to vote with their money in the direction of sustainability, in the direction of philanthropy, in the direction of altruism, businesses that focus on those things.
Well, to some extent, these kind of things have to emerge, they have to evolve, and each are subject to natural selection. And so the variations of conduct and behavior, the traits that people exhibit will either be selected for or against in the ecosystem that they're exhibited. And so if people are doing things in an ecologically sustainable way is not a new concept. Native peoples almost everywhere in the world were more or less in homeostasis, harmony with their environment. And so this concept of saying, well, consumerism and pollution and waste and so forth, we need to fix that. That's sort of a temporary aberration. And it happens at all kinds of different scales. People don't defecate in their own bed, in their own house. Yeah. Because the people who do got disease and got selected against. Yes. And so that kind of thing isn't because a government or a tribe said do this or don't do that. That is something that communicates their survival information, and that's why religions succeed still, because they package the infinite realm of choices into a recommended set that you don't have to figure out why those are recommended and the others are not. You can just on faith say, well, this is a recommended set that I can trust, that's been debugged for a long time. Yeah. And so having fish on Friday, that's the rule. Or you can say, well, maybe that makes me have a diversified diet and makes me have trading relationships with people in a different environmental system, so that if there is a change in the climate and our desert food doesn't work, our fishing friends will be able to feed us, and the fishing people, if there's a red tide and we can't eat the fish, then our land friends will be able to. So you can analyze a particular meme or a trait that comes from a religion or a way of thinking and try and rationalize why it works. But you can also say, well, this one has survived for thousands of years in these different kinds of communities, and it evidently does work. And just take it on faith and say, well, if I do that, then life will be easier.
So the top-down sort of government and legislation does not work for enabling markets and people to make decisions and slowly come up with, through evolution, through mimetics, what ends up being the prevailing outcome.
Well, there's a role for that. Like if you were to put two political equally democratic vote, like should we build a sewer treatment plant? Should we build a highway system? Should we have air traffic control? Should we do some of these things that require kind of a centralized top-down type of decision making and resource allocation? Like the average voter might say, no, we don't need a new freeway in the other side of the world or country. Mm-hmm. And so their vote on that decision might not be the best overall choice, the best overall vote. And so having a representative democracy where the local people who understand what the traffic is in that area say, well, we need this, and the people who don't really understand what the dynamics are, they think, their issue is more important, then they each, communicate that to a representative that then communicates that to a distributed but somewhat centralized decision making. And so that's proven to be effective, and more effective than a theoretical, ideological, pure one-for-one democracy.
Yeah, and modernizing democracy will take its route kind of as we went over the last over 200 years and figuring out how to add amendments and modernize it. I think we'll see a little bit more of that in the next couple decades as well. Especially with the proliferation of technology, what's actually going to happen to government and to democracy will be very, very interesting. Okay, I want to touch on this at least for a little bit. As we get to the conversation about a singularity, maybe we touch on technologies that are enabling such a process. So one of the favorites that you and I are both very familiar with is blockchain technology. And so having a digital ledger that's decentralized be in use for so many different applications of life such as currency and the way we exchange value, such as even potentially voting systems, all this good stuff. What are your thoughts about the industry, and what are your thoughts about where it's going to go?
Well, so we're very familiar with command and control, centralized government systems and representative democracies and that kind of thing, which is a way of organizing a tribe or a nation or a religion or that kind of a meta structure. And I sort of look to genetics and biochemistry and life and biology is not centralized. It's fully decentralized, it's fully distributed, it's peer-to-peer. And so if you were to make a list of what are the characteristics of blockchain and Bitcoin and these things, that they're decentralized, that they're immutable, that they're distributed, those things that you would describe Bitcoin are the same as describing biology.
Yeah.
And biology, well, it's not immutable, it's mutable, but it also is subject to Darwinian natural selection.
Yeah.
And so those random species and choices, either they survive or they don't, based on their characteristics, and that can be different in different parts of the world, in different ecosystems. And so blockchains, there's not one of them, there's many different kinds of blockchains, and to me, those are like different species of creatures. Yeah. And so these different species, whether the Ethereum blockchain or the Bitcoin blockchain survives or goes extinct and thrives or is in a niche, will be a function of not just its characteristics, but how those characteristics map to the ecosystem that it's in. Yep. And so if a distributed system like biology and life functions in a network type way, so will these blockchains and distributed information flows. And so in both cases, for me, it's information flow across the network. And so whether a gene or a trait propagates through many species of life would be the same as through different kinds of digital blockchains and distributed ledger systems, in that they're a flow of information. And there are things that have evolved over billions of years in the flow of information in life, which is carried by genetics and DNA and the coding and metabolism and sort of the biochemical ecosystem. That same dynamic will likely happen if the flow of digital information, and that's not just blockchain in isolation, it's how does digital information flow across the internet, across the world, not just in how do I get a bit from me to you. Well, that's the internet protocol, that's the transmission control protocol, and then how do you pass it on to the next person? Well, that's the internet protocol. So there we have TCP IP, and then there's file transfer protocols and verification and so forth. And blockchain has evolved out of that, in that it's another layer of protocol on the internet of how do I give something to you and that you then have it and I no longer have it.
And that it's on a ledger.
Yeah. Yeah. And that's a consensus ledger, which is the mechanism that is used to keep a record of me giving it up and you getting it.
Rather than a centralized one.
Well, and so historically that's been done by, for example, banks. That I tell the bank I'm going to give it to you. The bank says, okay, it's off your ledger, it's on yours. Mm-hmm. And if there's a dispute, we can both go to the bank and say, well, what happened? Yep. And so blockchain takes that and distributes it in a similar way that genetics works. That the record of when I transferred something from me to you is held not just by one bank, but by millions of different banks, if you will. And those would be nodes on the blockchain that are recording each transaction. And that's a distributed system, just like biology.
But biology never had a ledger of the last 4 billion years.
Well, DNA genetic heritance is kind of a ledger of the different genes and species of a species and all of its ancestors. And that all the different species are basically cousins of each other, and that so we're related to mushrooms and trees and fish and so forth.
But we don't know those 90 million species that have died.
Well, that's right, but there is trace of them in our genetics.
There's trace of them, yeah.
And so one of the problems with Bitcoin's blockchain, for example, is that it takes a lot of energy to propagate, to replicate. So it takes a lot of energy to stay alive. And species that take a lot of energy to stay alive have gone extinct. And so one of the things, the characteristics of blockchain, of Bitcoin's blockchain, is that it uses a mechanism, proof of work, that requires a lot of energy to replicate itself. So it's saying I need many hamburgers to reproduce. And that has a side effect in that there's a lot of that energy is wasted. And so if it could be more efficient, it would be more likely to survive longer, over millions of years. And then the other thing that is different in biology is that biology doesn't keep a record of every single transaction, and that there is some representation of dinosaurs and clams and fungi in our DNA, but not a complete record of all of everything that happened. And so Bitcoin's blockchain at the moment keeps a complete record in a very energy and efficient way, and those are kind of two strikes against it for long-term survival.
Yeah.
And evolutionists decided, well, like, which transactions do you keep on the ledger and which ones do you just ignore or forget?
Or pass off to another blockchain that can process them faster.
Well,
then
so you could process faster, but you have to, like if somebody bought a pizza 2,000 years ago with a blockchain, is it really important to remember that transaction?
Probably not.
And so the architecture of remembering every transaction may be overweighted and like an obese algorithm that may have a lower chance of survival than one that forgets.
Correct. Exactly. And so do you think that's part of our future, is a blockchain that forgets?
Yeah. I think that blockchain is like genetics. It's like DNA. It's like species. So each different kind of blockchain is like a different species that has, like, some are turtles and some are rabbits. And those have different characteristics, and one or the other might win the race. They might both finish, but one might be faster, the other might be more reliable. And so what happened in genetics is there were a relatively small number of species, and there was an innovation in species, like sensors, like eyes, evolved, and there was changes in the climate, and those led to a Cambrian explosion, it was called, where there was 3.5 million new species emerged very quickly. And so we may be in the pre-Cambrian explosion era of blockchain distributed systems.
That is a really good way to put it.
In all likelihood, there will be millions, not 10.
And then and then towards the end, there will be a human race, so be it, of the technology as well, as in there might only be 1 or 2 or 3 in use that are very similar to currency as well. When currency was birthed, it was like a Cambrian explosion in terms of currencies, and now there's one per country, pretty much. So we might see something similar, convergence into the most popular blockchains, into the ones that provide the most utility for humans.
Yeah, and there are plenty of niche species that, this one lives under deep sea volcanic vents, and where it's the only one that can live there, and the others it's inhospitable. And so it's having humans view themselves as the dominant species, but in terms of number of individuals or weight of living matter or number of species, humans are a tiny fraction of life on this planet, and that microbes make up most of it. And Dawkins would say, well, humans, the microbes told evolution to make something to carry them around. and so we evolved as transportation for microbes.
Yeah.
And Bruce Domner would say that like we're a species that, or these complex species have emerged on Earth for now, but mostly it was microbes. It still mostly is microbes. In the future, likely will be microbes.
Okay.
And these complicated human-like things are temporary.
Mm-hmm. Yeah. Okay, so on our way to the convergence of all of these technologies, do you think that artificial intelligence, what do you think about genetic engineering, neural laces? What do you think about space colonization and where we stand geopolitically as we compete with other countries to be the first to come up with these technologies? What do you think about that?
Well, that's quite a list you gave. I'm in favor of all those things.
Yes, likewise.
Like
Yeah.
genetic engineering and robotics
Yeah.
and AI and space. And
Likewise, but how do you feel about the sort of geopolitical kind of stressors that we're sort of facing with certain countries that are wanting to, there's so many existential threats are now looming because of the advances of these technologies. Even though we are very in favor of them, we're in favor of them in very benevolent and prosperous ways, and we're not in favor of the ones that extinct the species. So elaborate for us.
Well, I think people are afraid of new things generally, and that these, genetics, robotics, nanotech, AI type of technologies, they can be good or they can be bad, just like fire.
Yeah.
And that, fire, it can burn you, it can burn down your whole village, but it also is something you can cook with and you can transport yourself with and be warm and so forth. So bad things will happen with any new technology. But it also can be directed largely into good, useful purposes.
Do you have a general principle or two that you abide by when it comes to developing new technology into the world? Because things like running the artificial intelligence or running the edited genes on a network that is closed might be ideal. So do you have something like that?
Well, proceed with some caution and care, that until you know whether this fire will burn down a village, it's best to experiment with it in a fireplace, a place for experimenting with fire. And so these things, once they become kind of evident in the culture, they will evolve and persist regardless of what a government or society says to do with them. And that Kevin Kelly has this concept of the technium, which is like technology evolving complexity and biology or humans evolving complexity, and that they're both happening by natural evolution.
Yeah, correct.
And that can't necessarily be stopped, it can be used for good. So.
Yeah. Okay. I appreciate your very optimistic perspective on it. I also carry a very optimistic perspective on it. I really try and also be realistic, and that's what we do on Simulation is we ask about a lot of realistic scenarios that are sort of looming over our heads with things like wealth inequality with these technologies as well. Do you have any thoughts around 8 people having as much wealth right now as the bottom 4 billion and kind of instability occurring from that? Of course, Pinker's right. Overall, we've gotten a lot better as a society, but there's never been this stratification.
Well, so never is a long time, and if you look at people, there's 6 billion more extra people that here now that weren't here 100 years ago. Mm-hmm. And that the driving hidden factor in this is breeding and population. That of course, when you 7x the number of individuals, it will put strains on the ecosystem, and it'll exacerbate certain things like inequality. That it's not so much that subsistence level people are worse than they were 100 years ago. It's just that the ultra wealthy people now can exist that couldn't have even existed 100 years ago. There were no private planes or yachts or, that kind of thing 100 years ago. And so the really pressing force on this is the population growth, and there is driven largely by individual people being seen as a farming resource, a labor resource, or a warring resource, and that the survival strategy that was useful in the past was to use human labor to generate wealth. And now technology can generate wealth without the human labor, so breeding more people isn't necessarily better, it's actually a burden. And so the places where people are better educated, especially where women are better educated, the population growth is now flat or negative.
Correct.
And the places that are still subsistence farming, agrarian type things, the population growth is still strong. And so that, as long as that continues, there will be a disparity in wealth, but it doesn't mean that the bottom tier of the world society is being pushed down.
They're also coming
life
up.
Comfort is coming up.
It is
too.
It is, but if their life comfort is coming up at this rate, and in socioeconomic status, theirs is coming up at this rate.
Yeah, well, so this may be a speciation event where
Let's talk about that.
There's like plants and animals, and the plants might be jealous of animals because they can move, and the animals might be jealous of the plants because they they have a more comfortable life with less need for hunting. So there are advantages and disadvantages, but they become different species. And so it may be that the technologically empowered humans will become a different species from, for example, the religious fundamentalists.
Those that are not technologically empowered.
Well, or choose not to be. It's not that they couldn't be, but
some will choose not, and some will not be able to afford to.
Well, so afford to implies that there's a investment of capital in people to enable them to grow in wealth, but there are many examples of the wealthiest people in the world who started out with almost no resources.
Absolutely, absolutely.
So
that's totally very, especially in economies like Africa coming up, that there's so many potentials for new billionaires to be made. Now, with a technology like an iPhone, that once you have enough money to get a smartphone or a laptop to connect you to the internet, then that sends you up on a growth curve like that. Similarly to once you get once you get the monetary amount to be able to afford something like maybe augmented reality or a neural lace or whatever it may be, that you can then go exponentially increase as well. There are going to be people that choose not to, all that stuff. So do you think that there will be then a speciation in terms of people that are technology equipped and ones that are not?
I think there's both speciation and recombining happening all the time.
Okay.
And where species become distinctly separate, meaning they can't breed with each other any longer, that's usually because they're occupying different niches. Yeah. And they've become specialized to that niche. Yeah. And so an example is maybe the Amish becoming, or focusing on sort of agricultural technology avoidance lifestyle. Yeah. Where the super techno-dependent people who need artificial insemination and C-sections to breed, and that they can't even breed biologically together. They must have technology to just reproduce. And that those people eventually may not even be able to breed with the regular agrarian type of people. And then you have two species. There's sort of the techno people and the anti-techno people.
Okay, so we are looking like we're moving into the conversation about the merging of the different conversations that we're having and the different technologies that we're developing. So what is the process looking like for us to achieve the singularity? Because there's a difference between a singularity and the singularity. A singularity is the black hole in the center of a galaxy. The singularity is the merging of humans and technology to a point of such sophistication that there is. You take it over.
Well, so the singularity is a term that comes from physics, and it was originally coined to describe the event horizon around a mathematical point where things fall out of the model, and that became to be known as the singularity is the event horizon where you fall into a black hole in cosmology and in space, and that turned out to be predicted by Einstein's field equations and observed in cosmology and astronomy, looking for central points of gravity in a sense, and that are black holes. And so the term basically means change into unpredictability. And the term was repurposed in the 90s in science fiction, and then later in Ray Kurzweil's book called The Singularity is Near, to describe the evolution of technology and the technology becoming more complicated and more sophisticated, and that enabling new kinds of things like the arising of intelligence in machines, most notably the internet. And so if the way Ray would describe the technological singularity would be the time at which the internet becomes smarter than people, or collective humanity of people. And the 100-year trend of computers and machines and the internet becoming smarter and smarter, it has been tracking for 100 years in this exponential path. And if you just forecast that a little bit further into 2029 or 2045, the internet will most likely be smarter than all people combined.
Yes.
And that's and what happens when that happens is unpredictable.
Yes.
And that's a lot of what can be said about that. And it may be good, it may be bad, and that's probably a function of perspective. And
it kind of loops us to what we were talking about with technology, that there is the potential for it to be very, very good, like fire, or the potential for it to be very, very bad.
Yeah, or somewhere in between.
Yeah.
Like people are able to remember things, and they're able to learn and know things. And so Google is really good at learning and knowing things, better than any person.
Yep.
And so the fact that you can ask Google for anything,
Yep.
And it generally has a correct answer, is already way better than people.
Yep.
And it hasn't necessarily hurt society or people, maybe librarians or something that much. And so that's a knowledge singularity as opposed to an intelligence singularity, where the capability of the machines has exceeded people
Already. The knowledge singularity has already occurred.
Yeah.
Okay.
And so how do you process that knowledge, which might be intelligence, is already pretty good and getting better on this exponential pace, as Ray describes in his book, that forecasting it forward, it will get better much faster than our intuition would have us think. And so the ability of the technology to learn, for example, is accelerating in its capability, where it's not just a little better each year as a person might be, it's twice as good each year. And that has a compounding effect in that when you go from 2 to 4, well, that's not so noticeable, but when you go from 4 to 8 or 8 to 16, then it starts, you've gone from 2 to 16 in a short time. And so that's where people are taken by surprise of, well, how did this get so good so fast?
Yeah.
I didn't really feel that coming instinctually.
So what about the intelligence singularity?
Well, that would be the intelligence playing Go, playing chess. Like recently, a test out of Stanford of how accurately you can read Wikipedia and report information on it. The software has beat humans in the last few months.
You just go and shake someone's hand in an event, and they're like, "Hi, my name's Paul," and then all of a sudden, you just don't even listen to their name. Let alone when you read an article, how much of it do you actually retain? So the intelligence singularity is already occurring with Go and with chess and with even being able to beat out more complicated.
Or drive a car, or fly a plane, or trade stocks, or be a lawyer. There's a lot of things that an AI systems are able to do better than humans.
Okay,
already.
so then that becomes an intelligence singularity in Go, or in flying a plane, or in trading a stock. So there's intelligence singularities in these different domains. But now, what is the grand intelligence singularity?
Well, so you could say, how smart is the internet? And is the internet conscious?
Yeah.
And so that definition of a distributed set of subsystems that have a consensus opinion, well, that is a kind of form of consciousness. And that the internet likely already has that. But the internet isn't just electronic. There's like 3 billion people in the internet. And so the complexity of the internet is 3 billion times more than the complexity of any one person already. And plus you add the information storage and the processing and so forth to it.
So you're saying we're already in the intelligence singularity?
Yeah. It's a hybrid system combined of biological components and electronic components.
And the biological components are us and our minds and what we've put into the internet, and then the electronic components.
But it's also the real-time processing power, where you can ask a question to the internet and the answer might come back from Google, but it might come back from a person.
So this is amazing. I'm really excited to have you back in the future and to unpack this more. There's so much to unpack here, and it's so exciting. All these different singularities across domains that have already been achieved. This internet singularity that is already has all of these different minds that have been uploading information to it, and there's only going to be the other 3 billion minds that are about to upload their information to it, and then there's going to be all of the artificial intelligence algorithms that are put into a place to be able to parse the data to make sense of it and to learn about me better than I know me. So there's so many great conversations past that will take this down. Couple last thoughts are: do you believe we are alone in the cosmos?
This is the Fermi paradox, and a variation of it that I like called the transcension hypothesis, which is if life is naturally occurring complexity, and it should evolve in other planets or other places, doesn't necessarily need a planet, that by common sense, that if it evolved here, it should evolve somewhere else. And the Fermi paradox is, well, if that's the case, then why don't we see it? Or see some traces of it. And that partly that's we haven't looked hard enough or long enough, and so it may just be a matter of time until we find evidence of it. And the other part of that is that as we are evolving to be a more complex planet and a more complex species, we're also becoming more energy efficient and more intricate. And so the chips in phones and the fiber optic network and so forth from outer space is becoming quieter and more invisible as it becomes more complex and faster and more sophisticated. And so we've evolved in a sort of disequilibrium where we're blasting TV and radio out into space and sending rockets here and there and all that kind of thing. And so it's a disequilibrium where we're spewing a lot of stuff out into space, and so people far away would be able to see it. But as we evolve to be more complicated and more intricate, we'll also be quieter and more efficient and more difficult to discover. Mm-hmm. And so the transcension hypothesis is that advanced life forms on other planets or in other places that are more sophisticated than we are have already gone to a much more efficient way of being that may be much more advanced and complicated than we are, and thus we just can't see them.
Cloaking.
Well, not necessarily cloaking, but not being
noticeable.
Not being noticeable.
Discoverable.
Yeah.
Yeah. So okay, so with the sheer amount of life and that is potentially orbiting other stars, and with the sheer potential of their evolutionary capabilities, they very likely have figured out ways to become less discoverable by advancing their technologies.
Well, their motivation isn't to be less discoverable, it's just to waste less.
To waste less.
Yeah.
And that's what we're doing right now, is we're figuring out how to waste less
yeah.
as well. Good. Okay, and then last question is, are we in a computer simulation?
Well, this is kind of a question of a different question about what is God. In that we touched on, as an infant, we have a mother who is an all-powerful, all-knowing, wise and strong being that takes care of us and all of our life. And so every person has a longing for their infancy and the kind of freedom that gives. And so as we mature and through puberty and hormones say, well, separate from your mother, the people still have a longing for that feeling, and 2/3 of people in the world say, well, there's a God that has basically the same characteristics of an all-knowing, all-powerful being. And so that both created our life and our world and runs it. And so this concept of a simulation is like saying, well, there is some God who wrote the simulation, and they have a plan, and we're just players in it. And that's a way that we rationalize and say, well, we're just in a simulation, and that's something that is saying, well, the person who wrote the simulation is God. And so the question is, okay, well, are they in a simulation, or what is the motivation of the simulation? And so, in my opinion, we're not in a simulation. We're in, a universe that has certain characteristics. But I think it's a distributed, decentralized system, and that there isn't a command and control center. There isn't an all-powerful being, and that would be this God who wrote the simulation that we're in.
Yeah. I love thinking about it as the greatest experiment ever. Being able to tweak all of the different variables, the proximity to the star, the brightness of the star, the mass of the planet, how many beings evolved when they evolved, etc. All that good stuff is super interesting to be able to analyze. And so you're on the side of no.
Yeah, there's another take on that. Is that like mathematical models that try and simulate, how a flower grows or how the climate works on a planet are designed using a language of mathematics that is sort of internally consistent but limited in its capability. And so there's a saying in mathematical modeling, which is some of my background, that all the models are wrong, in that like your model is incomplete, and that you design it to simulate something that you observe, but there's maybe some characteristics of how this flower grew that I didn't know about, and they're not in the model, and so the model isn't the flower. And the sort of like saying the map of a territory is not the territory, or the menu is not the food, and that the simulation is not the reality. It's a lesser than version of the reality.
Oh, interesting. Okay. So the simulation itself is not as, it's a lesser version of what we experience in this reality.
Yeah, and if we could understand all of the aspects of physics and chemistry and so forth, then we might be able to make more accurate models, but we don't understand everything. So.
Reese, what do you think is the most beautiful thing in the world?
I would say ecosystems, like life, that we're both part of and dependent on. So.
Yeah, exactly. And that's a really great way to loop it all the way back to what you were teaching us at the beginning. Ecosystems are a very, very beautiful and profound thing to be able to both understand and immerse yourself in, but also to be able to go outside of what you know about them and go and learn more. And so that's kind of the 99% and the 1% again, the control, the free will, the conscious ability that we have, and then just our analysis and understanding of being a node in the 99% of the network functionality of society across economics and politics and memetics and cultural systems and even biology, of considering eating a banana, what actually goes into that from the last day and the last couple minutes and even the last millisecond beforehand or the last million years beforehand, and the perspective from your perspective versus someone else's perspective. So this is amazing. Ron, what do you think? Any thoughts?
Yeah, as a matter of fact, you scheduled an appointment for 3 o'clock, and
we should go to Elisa now.
We're running late.
Yes, we should get a photo of Reese for our upcoming book that we're working on. So we have a simulation book that we're working on where we're going to take pictures, beautiful pictures of our guests. We'll release more information on that soon. We hope to use it as a piece to inspire people as they flip through and look through all these diverse people and what they're building.
Yeah, she left.
Okay. That's okay.
That's
okay. We'll figure out how to solve it. Okay. So yeah, that ended up being a longer session than we planned, but it was very powerful, very good. I really appreciated having you. Thank you, Reese.
Well, thank you.
We'll put some links in the bio as well. Reese, are you Reese_Jones on Twitter?
Well, I don't care for Twitter that much, but yeah, I'm Reese_Jones on Twitter.
Reese_Jones on Twitter, or we also have Reese's LinkedIn profile as well. He has I actually really like Reese's banner. It's brain mass to body mass ratios, and how humans are just up in the top corner. These are the things that drew me to Reese and his just polymathic understanding of the worlds. So guys, if you had a good time, if you thought that this was useful content for you, please give us a like, comment, subscribe, share it with other people. Find us on Patreon. We're currently giving away exclusive content. We're giving access to live events, guest Q&A, all this stuff. So join us on Patreon. Shout out to Ron Vargas for our director and producer, doing an amazing job behind the camera system. And that is it. We'll catch you guys again soon. Thanks for tuning in. And on the way out, we'll give you the
Woodies.
Merch coming soon. Do you believe we're in a computer simulation? Woo! See you soon.
Go ahead, talk amongst yourselves.